Okay, students. Today we are going to discuss about the another set of past paper questions which are under units and dimensions of A-level physics. Okay, the question number 21 is from past paper 2012. Consider the following statements made about the information that can be obtained from the dimensional analysis. Okay, that can be obtained from the dimensional analysis. Okay, this is the question. The statement A says numerical values of constants of proportionality that may appear in a physical equation can be determined by dimensional analysis. But it's telling the numerical values. Numerical values. Numerical values we cannot derive or we cannot determine using the dimensional analysis. That's we already in our previous chapter also we have done the pendulum is proportional to L, M and G, okay, and proportional to L and M and G. Then finally we found the equation like this: K into root L over G. In that sense, the K, the value of K, we could not determine using the dimensional analysis. So the statement A is false. Statement A is false. But we can determine this quantity based on the experimental value, based on the experiment. So by the dimensional analysis, we cannot determine the constant value of K. It means numerical values of constant of proportionality that may appear in a physical equation cannot be determined. So the statement says can be determined. So it's false. Statement B says the numerical signs of constant of proportionality that may appear in the physical equation can be determined. Also, we cannot determine the sign. Also, we cannot determine the determine the sign of that constant values of proportionality. Okay, so the statement A is false and also the statement B also false. The third statement, statement C says the units of constants of proportionality that may appear in a physical equation can be determined by dimensional analysis. Yes. In an equation, let's say E is equal to, what is that? HF. It means Planck's constant. This is what? Planck's constant. Okay. This Planck's constant we can determine using the dimensional analysis. We can determine the dimensional analysis. So the statement C is correct. We can determine the dimensions of the constants, proportional constants, but we cannot derive or we cannot determine the constants values or signs. It means, so the question number 21, the statement C is only correct. So the answer number is 3. The option number 3 is the right answer. Okay, then SI unit of Planck's constant. Yes, SI unit of Planck's constant. I think this question is continuously coming from 2009. Yeah, continuously coming from 1990. I think so far we have met this kind of questions, that Planck's constant related to the Planck's constant dimensions and units. I think this is the third question. Okay. So please remember the SI unit of Planck constant. Then you can directly answer these questions without deriving or using these formulas and these things. If you can remember this one, okay, then you can directly answer these questions and it will reduce your time to do this question. Okay, so anyhow, the Planck's constant is E is equal to HF in this equation. The H is the Planck's constant. So the energy E is Joule. Energy E is measuring by Joule, and this is a frequency. The frequency is second minus 1. It's a unit. Okay, the referring 1 over T, the dimension is, and the unit, SI unit is second minus 1. So it means H is equal to what? J is over S minus 1. So H is equal to the unit of H is, SI unit of H is Joule second. Joule second. The answer is option number 2. Okay. 23rd question. It's from 2014. Question number 23. It's from past paper 2014. So the question is, as far as the units are concerned, which of the following quantities differs from the rest? Differs from the rest means one of the quantities differ from others. Differ from others. We will check one by one. First one is rotational kinetic energy. So is energy. Its energy means it's measuring by Joule. Okay, so energy. So rotational kinetic energy. The second one is mechanical potential energy. Yes, also energy. It's also measured by Joule. Okay, the internal energy also measured by Joule. There should be, because it's energy. All are mentioned as energy. Work is also, the work means work done. So work done is also what? Measuring by Joule. Measuring by Joule. What is power? Power is, you might know, power is work over time. Work over time. It means Joule, measuring by Joule second minus 1. So the power is differs from the rest. Differs from the other 4. So it means the answer is 5. The option number 5 is the answer. 23rd question. The option number 5 is the answer. Okay. Then question number 24. Which of the following quantities are dimensionless? Which of the following quantities are dimensionless? The first one is relative velocity. Relative velocity. What is relative velocity? For example, if A is going, if A is moving in this direction and B is moving in this direction. So the relative velocity. So you will study later what is relative velocity. Relative velocity, we are determining the velocity based on the one frame. Based on the one frame. So it means referring one unit to another one. Referring one unit velocity to another one. It means it is just the difference between two velocities. It will be difference between two velocities. For example, VAB means, so VA minus VB. If you take in one direction, so we will discuss later. Actually, the VA, so the relative velocity is the difference between two velocities. It means the final results should be in velocity. So the dimension should be equal to the velocity. So it cannot be dimensionless. The relative velocity cannot be dimensionless. What about the relative density? Relative density, we are referring the density of the substance to the water. Refer to substance density, refer to the water, means comparing with the water density. So it means density over density So the relative density doesn't have dimension. So it means statement B is correct. Statement B is, that means relative density is dimensionless. Okay. Same like relative humidity. Also, we are determining the percentage of the humidity based on the saturation vapor pressure. Saturation vapor pressure of the actual vapor pressure. We are determining the percentage of actual vapor pressure based on the saturation vapor pressure. That is relative humidity. Then our pressure over pressure means also dimensionless. So the B and C are dimensionless. It means B and C only the dimensionless. It means the option number 3 is the correct answer. Okay. The fifth one is 25th one. Electron volt. What is electron volt? Is the amount of energy gained or lost by an electron when it's moved through an electric potential difference of 1 volt. That is, by mathematically or the experimentally, it's derived the amount one electron volt is equal to 1.6 into 10 to the power minus 19 joules. So it is energy. So the answer is option number 4. The charge is Coulomb. So number 1 is not the answer because it's Coulomb. Electron volt is a unit of energy. It's Coulomb. It's not Coulomb actually. So the potential is volt. Potential means it's volt. Capacitance means it's Faraday. Electric field intensity, it's also volt per meter. That's fourth one, not the fifth one. Not the fourth one, it's the fifth one. Fifth option. Also electric field intensity, its unit is volt per meter. So the answer is option number 4. Question number 26. A, B, C, and D are physical quantities having different dimensions. It means dimension A is not equal to dimension A is not equal to dimension B and also not equal to dimension C and also not equal to dimension D. Okay, dimension D. So that is different dimensions. And K is a constant. So the dimension of K is equal to what? 1. Dimensionless means what? The dimension of K is 1. Consider the following relationship. Okay. Let's say, what about this A? K A cube is equal to B. K A cube is equal to B means K into, we will equate the dimensions of that formula. So A cube, dimension of A cube, it should be equal to B means, yeah. So K is equal to 1 into A cube. So dimension of A cube is equal to dimension of B. This is made possible. This is maybe valid if B's dimension as equal to the A cube, means this equation is possible. This equation is valid. Okay. Then what about D is equal to AC means then D is equal to AC. So dimension of D is equal to dimension of A into dimension of C. This is also possible. This can be valid if D dimension equal to product of A and C. If D's dimension is equal to product of A and C, this can be valid. So A can be valid and B also can be valid because of it satisfy the conditions. What we have derived. Okay. What about C? C means dimension of A dimension of A is equal to dimension of K into dimension of B. Dimension of B. It means dimension of A is equal to K dimension is 1. So there is no. So it should be dimension of B. No, this cannot be valid because A and B are, A, B, C are having different dimensions. A and B, C, D are having different dimensions. So this is false. This is false. This is not equal. So it means A and B are valid. A and B are can be valid, but C cannot be. C cannot be. The answer is A and B. The statement A and B are valid. Okay, dimensionally valid. And the C is not even dimensionally valid. Okay. Unit of pressure. Unit of pressure, it's very simple. We know that pressure, what is the pressure formula? Force over area. Force is kg ms minus 2, and the area is meter square. So if you put, if you replace the, if you represent the units in the formula, so it is coming kg m minus 1 s minus 2 is direct answer. You can choose as answer number, option number 3. Okay. Okay, we will see x, y, and z represents 3 physical quantities with different dimensions. With different dimensions, same like previous question. Huh? So please remember, when they are saying different questions means you just note somewhere here. Okay, dimension x is not equal to dimension y and not equal to dimension z. Dimension z. This is the data, given data. They can be combined to form another physical quantity P of the form. So it is like this. They can combine like this. Okay, they can combine like this. It means what? AX. A into X is what? According to the equating the dimension of this equation, AX also dimension of P is equal, AX is equal to dimension of P, and also BY also B into Y is equal to what? C dimension of C into Z. C into Z. This is the data. Okay. Yes. So which of the following expressions has different dimensions from the rest? Different dimensions from the rest. So we have to determine all these. So what about the AX dimension is P? AX dimension is P. We know that one, no? Yes. What about AX minus CZ? AX is here. CZ also there. So this one is P. So this one also P. So deducting from the same quantities, also giving the same quantity of value, same quantity of value. So this also, the AX, so AX minus P also having the dimension is dimension P. Dimension P. So what about AX CZ over BY? AX is equal to what? AX is equal to P and CZ also P. And what about BY? BY also P. So ultimately, this formula's quantity also dimension is P. Okay, dimension also P. So P is gone. So P is remaining. So what about BY squared? BY squared is also P squared. Sorry, P squared over P. The result is P. Result is P. What about BY into CZ? BY into CZ. BY is what? P. CZ also P. So the result is P square. So the different physical quantity is By into Z. This means the option number 5 is the correct answer. Option number 5 is the correct answer. So AX is equal to same as P. AX minus CZ both same as P. Subtraction is valid. AX into CZ over BY is this one, and BY square is over P also the same, and the BY into CZ also this one. So this the first one is the correct answer. Option number 5th. Okay. 29. Which of the following is not a fundamental unit? Which of the following is not a fundamental unit? You may know that the fundamental unit of M is the length of the length's fundamental unit is M. Joule is not a fundamental unit directly. Okay, this is a derived quantity. Candela is a fundamental unit. Temperature Kelvin is a fundamental unit. Moon is a fundamental unit. So the Joule is not a fundamental unit. So option number 2 is the correct answer. 29 or 30. Question number 30. The dimension of the gravitational constant G are given by. The dimensions of gravitational constant G are given by. So we should know what is the gravitational constant formula. F is equal to G into M1 into M1 M2 into R square. So now only you have to know about the formula. F is equal to G into M1 over M1 M2 over R square. So we know force. If you take G is an object, then F into R squared over M1 into M2. So if we know that dimension of force ML T minus 2, R squared means L squared, M1 M2 means M squared. Replacing this appropriate units, then we will get the gravitational constant. Dimension of the gravitational constant is M minus 1 L cube into T minus 2. It means, okay, L cube into M minus 1 into T minus 2. The option number 4 is the right answer. Okay, in this video, this is the last question. Okay, dimension of Planck's constant. So Joule is work done. Directly we can get from the E is into HF formula, as we know. Okay, so E over HF, energy is ml square T minus 2. And F is T minus 1. So the Planck's constant, unit of Planck's constant is ml square T minus 1. Thank you very much. All the best. We will meet in the next class. Please share to your friends and ask them to subscribe. Then they will not miss the video series or this lecture series in future. Okay. Thank you very much. Good luck.